Thank you, guys. Okay. Okay, so here's a little bit about me. I'm a co-author of the NIST Digital Identity Guidelines. These are the authentication and federation guidelines that are used by the US government. I'm a board member of the OpenID Foundation and ID Pro. I was named one of the top 100 leaders in identity. I hold a certification in identity security systems professional. And I'm also a scuba diver, so very happy to be here in Indonesia. Unfortunately, I won't be able to dive on this trip, but I hope to come back and see you guys again soon. I work for Ping Identity. So Ping Identity does a variety of different services for different companies. We serve over half the Fortune 500, so even though you haven't heard of us, most likely you have definitely used one of our applications or a piece of our software. We are in a large number of companies, and our target market is the global 2,000 largest companies in the world. So we help out with their single sign-on, their multi-factor authentication, any of their identity and access management needs. So we started out as a single sign-on company. That is by far our largest market still. We started in 2002, and we were not profitable until last year. So if someone is telling you that your startup not being profitable is an issue, tell them to go look at Ping Identity. We're now very profitable. We started out with single sign-on, moved to access management, to a directory product, released a multi-factor authentication product. We now have a machine learning product that just came out this year. So we'll talk a little bit more about that later. So I was looking at our product suite, and I was talking to my team. And my team is very special in Ping Identity. We are 7 people, and we look at the future. So we look at emerging markets, emerging technologies. We look at where the world is going. And I talked to my team, and I said, I am going to go halfway across the world, and I'm going to go to one of the most innovative countries in the world, one of the largest cultural cross-sections of the world, some of the most diverse management teams in the world. What do we have to share with them? What should we tell them so that the influence that they are going to have on the global economy can change for the better? And my team said this one. They need to be looking at the directory. That is where we can make the most impact. That is the part of our product suite and the part of identity and access management at large that is going to change the world the most over the next 10 years. So we already talked a little bit about what identity and access management is. It's a subsector of information security. And one of the things that we like to do in identity and access management is move the needle in a specific direction. So we think about a graph of usability on one side and security here along the bottom. So probably the most well-known technology in identity and access management is passwords. But passwords aren't really very good on this graph. They're not very usable. People are very bad at remembering passwords. They hate having to enter them. And they're really not very secure, right? They're fairly easy for attackers to guess, to brute force, to get through. And what's even worse than that is frequently when you forget your password, a site will ask you for a secret question. And secret questions are even worse on this graph, right? They're very bad security. They're easy to look up. What's your mother's maiden name? Where did you go to high school? Things like that. And they're very hard for users to actually remember. So what we want to do in the identity and access management field is move the needle on both security and usability towards solutions that are both usable and secure at the same time. And we realize that in order to do that, we actually have to treat each person as an individual. So part of the purpose of our directory product is to enable our customers, the largest companies in the world, to treat each of you like individual people. Like you're not automatons, like you go to different places, you have different behaviors, you have different security concerns, you have different risks associated with your accounts. So we have to treat each of you like individuals, and if we're going to do that, we can also deliver individual experiences to you using the same back-end architecture. So step 1 in that process is just having a clean directory. So we're going to go over 6 steps here, going from things that are easy, things that are very common, to things that are very difficult, and even things that are sort of futuristic and not yet in existence. So having a clean directory looks something like this. You have a name, a list of services or products that that person uses. You have an email, maybe a list of devices, right? So this is just a one by many list of attributes about the user, and everyone has these attributes, and they're very simple. One of the big problems that a lot of our customers run into is that they have multiple directories with the same people in them. So they have a directory of employees, a directory of customers, a directory of partners, but often they have multiple directories of customers, people who came in through the telephone, people who came into the store, people who came in online. And that creates a terrible user experience. So if I walk into a store and you're not aware that I called you 2 days ago with a problem, that's not a good user experience. If I call you on the phone and you don't know that I came into the store, that's not a good user experience, right? So we need to combine all these directories into clean data with one entry per person. And we're going to talk a little bit more about machine learning later. I'm so glad that Rafad came up and talked about Azure Cosmos, because that's one of the technologies that we use, and it's a great technology, but it depends on you having clean data. And cleaning up the data is the hardest part of making a great directory and a personalized user experience. So if you start with clean data, you'll be way, way ahead of your competition. Oops, I'm going backwards, sorry. So this enables very basic personalization, things like this. You can call the user by name. So step 2 is having a federated login. So when I say federated login, I'm talking about single sign-on system. So give your customer or your employee only one username and password to remember to get into all of your lines of business, all of your products, all of the applications that they need access to. And what that means is that you can centralize authentication. So if you fire an employee, you can go to one place and revoke that employee's access. Or if a customer has a mistake in their profile, you can go to one profile and change that mistake. So in terms of single sign-on, there are a few security recommendations that we have regarding usernames and passwords, as well as multi-factor authentication. And some of these are not intuitive, and they're new, because we've done a lot of research on passwords in the last 5 years, and we found that a lot of the things we thought were true actually are not. So having a smart password policy for your users entails a few do and do nots. So there are 3 do's and there are 2 do nots. So the first do is to allow ridiculously long passwords. So the longer the password, the more secure it is. And people are actually very good at remembering long passwords if you allow them to use spaces and special characters. So people can remember entire lines from plays. They can remember entire songs, right? I don't want to hear that you can't remember a 32-character password. You absolutely can. You know lots and lots of them. You can't remember an 8-character password that's entirely made of special characters and random digits. That I believe. But if we allow people to have ridiculously long passwords and they use passphrases with spaces and special characters in them, that's actually much more secure than them using a small password that's hard to remember that doesn't include any words that they're familiar with. Lastly, in the do column, we recommend that people compare to a breach corpus. So when I say a breach corpus, what I mean is that we know that many username and password sets have been breached. So the companies that were controlling them had a security breach, and they were leaked online. And we know that they're being sold on the dark web, and that attackers are using credential stuffing attacks to stuff those credentials into all of the banks that they have access to, on the chance that one of them will be correct, because lots of users use the same username and password everywhere. So we recommend that you compare to a breach corpus anytime a user changes their password or creates a new account. If we know that the password and username that they are using has already been breached, then we tell them you can't use that one. That's not a secure password. If you use that, this account is going to become compromised in a very short amount of time, so you need to pick something else. On the do not list, we have do not require special characters. So we should allow special characters, but not require them. We don't want to require specific kinds of complexity because it actually makes it easier to brute force a password. So if I'm an attacker and I'm trying to guess your password, I have to try everything, right? I have to try all the combinations of letters and numbers and special characters that there are. If I know that there has to be a number in there somewhere, then I only have to try this many. And if I know that there has to be a capital letter in there somewhere, then I only have to try this many. So if you require specific kinds of complexity in your passwords, it actually makes it easier for attackers to guess the passwords of your customers. And secondly, on the do not list, we don't want people forcing rotation. So we don't want users to be forced to rotate their password every 90 days. A friend of mine worked on a desk on Wall Street. They were required to change their password every 90 days. And what happened was that people make really predictable passwords. So everyone on the floor had the same password, right? Fall 2017, winter 2017, spring 2018. Right, so you force people to make passwords that are easy to remember so that they can change them every 90 days, and they're likely to make passwords that are similar to passwords that they've used in the past. And we know that attackers have fuzzing software, so that if they know one password, they'll guess a whole bunch of things that are similar to that password. So that's smart password policy. Let's talk about multi-factor authentication. So when we say multi-factor authentication, what I'm talking about is something in addition to the password that helps you prove that you are who you say you are. So this is either something you have, like a phone or a security key. So I use a security key. I use YubiKeys when I log in. So I enter my username and my password, and then I put in a YubiKey. I keep mine on my earrings. These are YubiKey Nano 4s. So I take off my earring and I put it in my USB drive. And it has a cryptographic key pair on it. And the website that I'm logging into sends me a challenge. The key cryptographically signs that challenge and sends it back so that the private key never leaves the device. So we need to get smarter about how we're doing multi-factor authentication. We talked earlier about knowledge-based authentication. This is secret questions. So we know that secret questions are really bad MFA. They're bad security and they're bad usability. I helped the University of Washington tear out their knowledge-based authentication system. They had data going back 10 years showing that 60% of users get their secret questions wrong on the first try. So we know that's a terrible user experience. We don't want to put people through that. We also know that one-time password over SMS is weak. So the publicly switched telephone network has extensive vulnerabilities. SMS can be sniffed with off-the-shelf hardware and software. And most importantly, it's easy to socially engineer phone number porting or device replacement. This is also called SIM swapping. So this is where you walk into an electronics store and you convince the salesperson to sell you a phone, and you say, hey, I'm going to tell you that I'm Sarah Squire, and you need to port her phone number to this new device. And then you're getting all my text messages and you can log into my accounts. So that's part of the issue with SIMs that we have, where we don't want SIMs acting as a second factor in situations where we have high risk. So situations where there is financial transactions going on, or situations where you have access to large amounts of personal data, very high risk transactions. It's fine for low risk transactions. It's very deployable. It's a good model, but for high risk transactions, we want to see something like an application that's not tied to the SIM, or a security key, or a biometric, something along those lines. So step 3 in making a great directory is API access. So we want to see something like this, where any line of business can post things to the directory. So if I call up on the phone, you now have my phone number, and you can say, hey, can we SMS you? We're going to put that in the directory, so that when I show up at the store, and I say, hey, I'm here to pick up a package, they then have access to that same directory row that was written by the call center. So we want everyone in the company to have access to the directory at the same time. What we see in too many companies is that the directory is built into the software for that line of business. And that's no good, because that means they're not talking to each other and everyone's having a bad user experience. So this is what the directory would look like after a post like that. We would have a JSON object here, so this can be any kind of JSON object. Directories don't just have to be strings. That has a type of SMS and then a phone number. We can also track purchases in the directory. So if you came into the store and bought a DVD of Star Trek: The Next Generation, we can track that, and we can change the way that your app looks the next time you log in. So if we know that you bought a DVD in the store, the store can write that as a post, an API post to the directory, and the next time you log into the app, we can say, hey, maybe you want to stream the soundtrack. Maybe you want to stream this as video. We can also use server logs and have those write to the directory. So it's not just lines of business that can post to the directory. We've seen people using Splunk and saying, hey, what's this person's top watch show? And then put that in the directory and say, this person watched Babylon 5 hundreds of times. So maybe we should change our interface to show them more of what they like, what they want to see. Maybe we should put that right at the top of the screen instead of putting it behind 4 different clicks, because we know that's probably where they're going to go. That's probably what they want. So we can change the entire interface based on the logs we're seeing of user activity. So step 4, machine learning. This is really cool. If you have clean directory data, there's a lot that you can do with machine learning. You can recognize where people are, and you can look at people like them. So it could recognize that, hey, I went to Jakarta, and here's what people in Jakarta are watching right now. So we can recommend things based on contextual information about what the user is doing, where they are, what other people who are in that context are also doing. We also like it from a fraud detection point of view. So we can see the pattern that unauthorized logins make, and it's different from the pattern of an authorized user. And we can use machine learning to determine those two and stop an attacker before they can actually get in. We talked about credential stuffing attacks earlier. We can see those happening as well, and we can see them across our customers. So we can use machine learning to look at that traffic, that API traffic, and say, this is clearly an attack that's going on in real time. We can do the same thing with distributed denial of service attacks and shut those down before they get any valuable user information. Step 5 is public open APIs. This is a really exciting part of the identity industry right now. What I mean when I say public APIs is that those APIs that you have that are open to all your different lines of business, that are open to your logs, that are open to different parts of your business to write to, you can open those up to the public. So people are used to seeing this in the context of fitness, right? So you go on a run, it tracks your GPS, and that can go to your calorie counting application, or it can go to your mapping application, because it's all open APIs. You can use whatever app you want, or you can write your own app to consume that data and chew it up however you want to. So this doesn't just apply to fitness, it also applies to finance. So right now in the UK, they don't have GoPay, they don't have digital currency on their phones. Finance in the UK and in the US is still very old. It doesn't have a lot of innovation. And one of the ways that we would love to see innovation happening is through open APIs. So the UK government mandated by law that the largest 9 banks in the UK have to open up public APIs for all of their customers. So that means that any customer of this bank can download any financial aggregation app they want to, any budgeting app they want to, any analysis of finance app that they want to, and pull in their own user data, that data belongs to them and they can do what they want with it. We're also seeing innovations in healthcare around personal data. So in the US, we have a big problem with patient matching, where if your primary care physician has a copy of your medical record and you want to go see a specialist, that specialist has to get access to that record. But those 2 doctors have to figure out which Sarah Squire they're talking about. And they don't have a universal identifier to talk about people. The best way to solve this problem is actually to use open APIs at the owner of the healthcare record to say, I want to go see the specialist, give me my data. I have legal access to that data. Let me send it to the specialist. So we're seeing that sort of legislation as well. And then we're also seeing open APIs in government. So if you want to get a visa from another country, if you want to open a bank account in another country, open APIs can allow you to get your identity data and prove it to a third party. So this is the last one. My team is very excited about this one. This is decentralization. And when we talk about decentralization, we're mainly talking about distributed applications, so the Ethereum network, distributed ledgers, things like that. And the problem we're trying to solve here is really pretty simple. It's a convenience problem and a privacy problem and a security problem. And potentially this solution could solve all of those. So when I go into a bar in Seattle, in Washington, in order to get a drink, I have to prove that I'm over 21 years old. So I hand the bartender a piece of plastic that was given to me by the state of Washington. And that piece of plastic doesn't just say that Sarah Squire is over 21. That piece of plastic says my full legal name. It gives that bartender my home address, which I'm probably very uncomfortable with. It says my height, my weight, right? All sorts of things that that bartender does not need to know. So what we want to see is a world where we have something we call verifiable claims. This is a working group in the World Wide Web Consortium. And the idea behind this working group is that we want a digital way to prove a true or a false. Am I over 21? Yes or no? That's all that person really needs to know. They don't need to know my age. They don't need to know my home address. They do need to know that that claim was issued by the state of Washington. So you might think that this is a good problem to solve with APIs. What if the state of Washington had an API and that bartender could pull up that API and say, hey, I've got Sarah Squire in front of me. Is she over 21, yes or no? The problem with that solution is that then the state of Washington knows where and when I'm drinking. So that's a privacy implication that we don't want to get into. The better way to solve this is for me to have a piece of JSON on my phone that says my ID number, yes, I am over 21, and then has a picture of me, and have all of that cryptographically signed by the state of Washington. So that just like I pass an ID that is difficult to forge to the bartender, I can pass this piece of code to the bartender, and that bartender can check that cryptographic signature and make sure that the state of Washington actually issued that information. And that is impossible to forge unless you break public key cryptography. And if you can do that, then the entire Western economy is coming down. So we have larger problems than me drinking when I'm not supposed to. So this doesn't just apply to bars, obviously. That's not the only problem we're trying to solve here. But it applies to identity proofing in general. Any facts that you need to prove about yourself to other people can be proved in a privacy-preserving way, in a way that is completely resistant to fraud. So that's what we're trying to accomplish with verifiable claims and decentralized identity. And this is not in production anywhere yet. It's all still very under development. So we're very excited about where it's going. We're investing in it heavily. So those are the 6 steps: clean directory, federated login, API access, machine learning, public open APIs, and decentralization. So I just want to reiterate to you the importance of this community at this time. Indonesia has a huge amount of innovation that the rest of the world needs to see. As I said, you're way ahead of us in payments. You're getting way ahead of us in software development and in innovation in general. And when you are innovating, as you are influencing the international community of software architecture, please do keep in mind these security concerns, these usability concerns, and this ability to scale personalization, to treat people as individuals, both from a security standpoint and from an individualization standpoint. So thank you very much for inviting me.